example represents the data for 80 new lamps. Those were tested for burning lifetime estimation, and the lifetimes were given to the nearest odd, and these are the 80 values. So from this data, our first attempt is to develop a frequency distribution. So we define the lower bounds and upper bounds of several classes, and we count the number of times the values fall in those upper and lower bounds. So we have the data for the observed frequencies. So the next step is to come up with the expected frequencies according to a distribution. For example, if we want to calculate the normally distributed frequencies, so we have to start with a mean value and the standard deviation. So I perform these calculation in Microsoft Excel, and we will compute the expected frequencies. So here we go. In the Microsoft Excel sheet, I have the lower limits of the classes XL and XU, and I have accordingly the observed frequencies in column C. And our first step towards computing the theoretical frequencies is to define the mean value and the standard deviations from the data. We have computed mu value, which is 1227, and sigma 345.3. So for these values, for a normal distribution, for every class, I can define in standard z-score lower limits and the upper limits by define as ZL and ZU. So for first class, this will be equal to the XL value minus the mu value. So I will pick it from its location. So mu value and divided by sigma value, which is at E6 position, and that's it. And yes, similarly, okay. So here something has changed. Well, the calculation has shifted to F cell. So there is no value, so mean value E, and the sigma value to be picked from the particular value here, this value from its respective cell. So I repeat these calculations for all of the classes, lower limits and upper limits, and then the area on the basis of normal distribution, which is the probability area under the normal distribution curve from lower limit to the upper limit. So this is possible with the help of normal distribution function. So I write here normal dot standard dot distribution. So it requires a z value. So I write here the upper limit value, and for cumulative value I write true, which means it is the area from minus infinity to this value, and I write here minus normal distribution and the z value to the lower limit, and I write here true. So between two limits, it is the integral evaluated at the upper limit, say from minus infinity to the upper limit, minus the integral from minus infinity to the lower limit. So that is going to be the area and between ZL limit to ZU limit. This is going to be the area, right? And if we have a normal distribution table, this calculation has to be performed accordingly. So we get the values from the table to compute these probability values. So if we compute the total area, so this should be equal to 1. So it's very close to 1. And then to compute the theoretical frequencies, which are based on a normal distribution, which is defined about this mu value and sigma. So we will multiply the probability area, probability times the total number of observations, which were in this case 80. We started with the 80 light bulbs, and these are their lifetimes. So if I compute the summation here, so it's close to 80, which is simply the sum of, which is equal to the sum of the total sum of the observed frequencies, and which corresponds to the total number of observations taken. So then on the basis of the observed frequencies and the theoretical frequencies, we compute the chi-square test, chi-square matrix, and on which we develop the inference whether a model, a normal distribution model defined about this particular mean value and sigma is appropriate to define the characteristics of the whole given data.